natural base e and natural exponential function. So the natural base e is approximately equals to 2.71828. Usually I would just call the base e 2.7. So base e is approximately equals to 2.7. You have to be aware that e is not a variable, it's a natural base. And then y equals to e to the x, or you can say f of x equals to e to the x. This is a natural exponential function. So on your decimal, just type y equals or f of x equals to. Usually I will just type y equals to and then e and then raised to the x power. So raised to the x power, and then they will give you a graph like that. And then how do I get these points? So do you see that on the graphing menu, on the upper right hand corner, there is a gear button. So you click on the gear buttons, then there should be a table icon. You click on the table icon, you select some x value. You can say x equals to -3, -2, -1, 1, 2, 3, 4, 5, so on and so forth. And then they will show this point, they will show the points on the graph. The one they black out, that is for the y-intercept. So they will show you the x value you selected, and then they will give you the corresponding y value as well. So it's extremely convenient. E to the x is a natural exponential function. And then how about e to the negative x? So e to the negative x, so that is a 1 divided by e to the x, right? So that one I should write right out for you. So e to the negative x is 1 divided by e to the x. So if you choose a very big x value, you will get a very large denominator. 1 divided by a large denominator is approximately equals to 0. So that's why e to the x is a decreasing function, and that is also called a natural exponential function. Same thing on the decimal, click the gear button on the upper right hand corner, and then click on the table button, select some x value, -1, 0, 1, 2, and 3. They will show you the corresponding y values and the points on the curve. And then when you click on the points, they will give you the x coordinate and the y coordinate. And then this is a decreasing function. So what are some other characteristics? So for both function, e to the x and e to the negative x, they are both positive, right? E raised to some power will never give you a negative. They are both positive. The domain x can be any values you like, and then the range, the curve is above the x-axis, the y is greater than 0. There is no equal because y equals to 0. Do you see this purple dashed line is a horizontal asymptote on the x-axis, and therefore both function, the y-intercept is at 0, -1. Okay, so for the TI graphing calculator, how do you evaluate e to the -1, -3, and -2? So you hit the second button. I am using TI-84 plus CE. The second button is in blue, and then you click the LM button. So take a look at the LM button. Do you see that there is a e to the x in blue? So that's why you need to hit the blue key. And then you hit the LM button, and then they will show you once you click that, they will give you an e, and then they will raise that to a base for you, raise that to an exponent for you, and then you can type whatever exponent you like, and I have some sample calculations for you. Now, I have some solve for x problem. So I have a equals to 2 raised to the third power plus 1. I want to find out what x equals to. Very simple. So we have a equals to 2 to the 3x plus 1. First of all, you have to write a as a base 2, which is a 2 to the third power. This is a 2 to the 3x plus 1. Now they have the same base, so we set the exponents equal. 3 equals to 3x plus 1, and then you just solve for x. 3 minus 1 is equals to 2. 2 is equals to 3x, so x is equals to 2/3. That is the first equation. Yes, it is pretty simple. And then the next one, you have 1/3 negative x plus 4 equals to 27. So 27 in base 3. What is that equal to? That is 3 raised to the third power, right? And then that 1/3, you can write 3 to the negative 1 power, and then you raise the whole thing to the negative x plus 4. In this case, you distribute -1 to -x and pass the 4. And then you have a -1 times -x plus 4, and then on the other side you have a third power. They already have the same base, so all you have to do is you set the power equal, and then you have positive x minus 4 equals to 3, so x is equals to 7. Pretty simple. And then the last one, not the last one, the third one, they have e to the 5x plus 7 equals to e to the -2. The base are already the same. 5x plus 7 equals to -2. And then you subtract 7 on both sides. You have 5x equals to -9. Divide both sides by 5. You have -9 over 5. And then that's the third one. The last one, they have the same base. It is just like solving an exponential equation. E to the x squared plus 4x equals to e to the 12. Same base, I'm going to set the exponents equal. 4x equals to 12, x squared plus 4x minus 12 equals to 0. And then you do a factor. This is x minus 2. And then x plus 6 equals to 0, and then x is equals to x minus 2 equals to 0, x plus 6 equals to 0, so we have x equals to 2 and x equals to -6. This is a zero product property. In order to apply zero product property, the other side must be equals to 0, so that is a times, in case you don't remember, a times b equals to 0, then either a equals to 0 or b equals to 0. If the other side is like a 12 or a 15, so for example a 12, there are many different combinations. 1 times 12, 4 times 3, 3 times 4, 2 times 6. You cannot say either a equals to 12 or b equals to 12. That doesn't make any sense. That only works for 0. And that's why we call this a zero product property. Alright, so that is the end of this video. If you like the way I introduce natural exponential function, give me a thumbs up, give my channel a subscribe, and I will meet you all in the next video for math content. Signing out.